Hello everyone, this is Shruti H. Machoguda and my combination is CZ. My college is Sri Siddheshwara Government First Grade College PG Study Center, Nargund, and my seminar topic is applications of EMF measurements in determination of redox potential. Let's start the topic and presentation on applications of EMF measurements. So let's start the definition of electromotive force. The difference between the electrode potentials of the two electrodes constituting an electrochemical cell is known as the electromotive force of a cell. This is the definition of EMF. So next one is the applications of measurement of electromotive force. Some of applications are described here, and determination of equilibrium constant, determination of solubility of springly soluble salt, determination of valence, and determination of thermodynamic functions, determination of pH of solution, potentiometric titration, determination of activity coefficient, determination of transfer number. So these all are the applications are applied in the EMF. So next one is the determination of solubility of springly soluble cell. This is the one reaction, and this is the mathematical reaction of the EMF. So next one is the determination of valence. The expression for the EMF of En of a concentration cell. E is equals to 0.059 divided by N log 10 C2 divided by C1. This is the formula of expression of the EMF and the concentration of the cell. So next one is the where N is the valence of the metallic ion in solution, while C1 and C2 are the concentration of the ions in two half cells. Examples: the following cell is constructed. Here is the reaction, and its EMF found experimentally is 0.029 volts. This is the reaction. So next one is the determination of thermodynamic function, free energy and enthalpy we see in this slide. So next one is the free energy delta G is equals to N minus N EF. So where N is the number of moles of electrons transferred and is equal to the valence of the ion participating in the cell reaction. So next one is the F stands for Faraday and is equal to the 500 column, and E is the EMF of the cell. So next one is the enthalpy. E is equals to minus delta H divided by NF plus TE divided by E divided by T whole P. So this is the temperature of coefficient of the EMF of the cell. So these are the case 1, case 2 and case 3 are applied. N minus N E F is equals to minus delta H, and this is the case 1. Case 2 is the N E F E greater than minus delta H. Then case 3 is the N E F E less than minus delta H. These are the cases are applied in the enthalpy of EMF. So next one is the determination of pH of a solution. A half cell is set up with the test solution as electrode. The EMF of the cell depends on the concentration of H plus ions or pH of the solution. The EMF of the half cell is determined by coupling it with another standard half cell and measuring the EMF of the complete cell. So next one is the commonly used strands electrodes are the hydrogen electrode, the quinhydron electrode, and the glass electrode. By measuring potential differences, hydrogen ion concentration can be calculated using the equation which gives the relation between hydrogen ion and concentration and voltage or potential. This is the reaction. E is equals to E naught plus RT divided by NF. So in Mn plus. Okay, this is the determination of pH of solution. So next one is the by using glass electrode. So by using electrode, the complete cell may be represented as AgCl and HCl glass solutions. This is the glass rod electrodes. These we can observe in this diagram. So EMF of the cell can be given by the expression pH E cell minus E. So this is the reaction of the, this is the formula. And next one is the potentiometric titration. Definition: a potentiometric titration is the one in which the equivalence point is detected by measuring the changes in the potential of suitable electrode during the course of a reaction. So next one is the experiment process. The indicator electrode is paired with a reference electrode and the two electrodes are connected to a electronic voltmeter. The EMF of the indicator electrode changes gradually with the change of concentration of ions caused by the addition of titrate from the burette. The equivalence point is indicated by a sharp change in electrode potential. So this is the experimental process of the potentiometric titration. So next one is the types: acid base titration, oxidation reduction titration, precipitation titration. These are the titration. So let's start the acid base titration. We can observe in this diagram when it's high and when it's low, and when it's medium acid in the titration. When we add some acid and bases titration, appearance of potentiometric acid base titration we observe in first diagram, and volume of. So next one is the potentiometric titration curve of an acid on base, where how it's curve and we can observe in this diagram. So next one is the oxidation reduction titration. So next one is the titration of ferrous ions Fe2 plus with ferric ions Ce4 plus in an example of oxidation reduction or redox titration. Fe2 plus ion is oxidized to Fe3 minus ion, while Ce4 plus is reduced to Ce3 plus ion. How it can change the electrons? So we can observe in this reaction Fe2 plus Ce4 plus Fe3 plus Ce3 plus. So this is the reaction. So next one is the, we can observe in this diagram. Next one is the apparatus for potentiometric titration of Fe2 plus with Ce4 plus. How can it works? We can observe in this first diagram. And next one is the volume of Ce4 plus added. So when we added the Ce4 plus, we can observe this curve and potentiometric titration curve for Fe2 plus ions and Ce4 plus ions. So next one is the precipitation titration. A typical precipitation titration is that of sodium chloride solution against silver nitrate solution. We know that already. Ag plus E and Ag. This is the reaction. So we can first observe in this diagram. We can electrode some Ag. So like this we can observe in this diagram, and how can it change the electrons. And potentiometric titration of sodium chloride against silver nitrate solution we can observe in this first diagram. And next one is the potentiometric titration curve, how it's acting on this diagram. So next one is the determination of activity coefficient. For example, the mean activity coefficient of the ions in hydraulic acid of molality B is obtained from the following equation once E has been determined. This is we can observe in this equation. So next one is the determination of transference number. The method employed based on measurements of cell containing the same electrodes with the without transference E1 divided by E is equals to so next one is where is the transference number TF refers to the negative of if the extreme electrodes are reversible with respect to positive ion and vice versa. So next one is the, for example, if the amalgam cell without transference AgCl, LiCl, lithium, so lithium chloride, AgCl, Ag, so like this is under consideration the corresponding cell with the transferred is, so this one is the AgCl, LiCl and AgCl. How can it's corresponding? So next one is the ratio of the EMF of these cells. This gives the transference number of lithium ion is Et divided by E is equals to TLi plus. So this is my small topic, and thank you one and all.